I'm Terry.
And I'm Lars.
And today, we want to talk to you about centripetal force.
Centripetal force goes hand in hand with circular motion. During circular motion, an object's speed remains constant, but its velocity continuously changes due to its varying direction. This change in velocity has to have an acceleration.
This acceleration and the resulting force must always point toward the center of the path. While we were spinning, our hands created the necessary force to keep us going around in a circle. As soon as we let go, this force was removed and we flew off in directions corresponding to our velocities at that moment. Well, now that you have a general idea of how it works, let's turn it over to Ball and Barry for the mathy stuff. When I swing this ball through the air, it'll maintain its circular orbit due to the centripetal force acting upon it, much like a satellite orbits the Earth. This force comes from the tension supplied by the string. But for a satellite, this comes from the Earth's gravitational pull. Now, centripetal force, like any force, is equal to the mass times the acceleration, where in this case, the acceleration is the velocity squared over the radius.
The velocity squared term means that speed is really important. If Barry spins too slowly, he won't create an orbit. But if he speeds up, he'll succeed.
Back to you, Lars.
Imagine a motorcyclist trying to make it around a loop. If he doesn't go fast enough, he won't overcome the pull of gravity and will fall halfway through. Uh-oh. What happens when the rider is able to build up the necessary speed? The motorcyclist enters the loop, and the track forces an upward change in direction. Notice how the force of the track against the tires always points towards the center of the circle. This push is the centripetal force that allows the motorcycle to complete the loop.
Now let's turn to race car driver Roxy for an example of centripetal force in action in our everyday lives.
One example of centripetal force comes from driving around a curve. As you take the turn, your tires apply a friction force, much like how the string applied tension to the ball. This keeps the car from flying off into the sidewalk. Remember that the force is proportional to velocity squared, so the faster you're going, the harder your tires have to work.
So there you have it. Centripetal force keeps objects in circular motion. If you'd like to learn more about science, email us at bswbproductions@gmail.com. And remember, if you've got a question,
we'll find the answer.